In this example, we'll talk about linked list. So what is linked list? So in order to create a collection or a list, we have two basic classes, or we normally use two classes. One of them is array list. So we'll say array list here, and we'll say this is uh, the list of integers, and we'll say this is values equal to new array list, and we'll specify a angular bracket to specify generic, and let's import the package. Now, so there's something else array list. Now, whenever you add an array list, let's say values dot add, and we'll say 4, then we'll say values dot add, we'll say 5, and we'll say values dot add, and we'll say 9. So let's say you have these three elements here. Now, if we try to print this element, let's say we have to use a for loop, and we'll say int I in values, and let's print this. If we try to print, so we'll say system dot out dot print. So if we try to print this I, so you can see the output here will be 4, 5, and 9. So it will follow the sequence which you have provided, right? But let's say I don't want to print, I want a new element after this 5. So before 9, there should be a new element called as 16. Now, in order to add the values, we can simply say values dot add. So if I write 16 here, this 16 will get added after 9. What I want is this 16 should be added before 9. Now, if you compare the values here, so the index number for 4 is 0. The index number for 5 is 1. And the index number for this 9 is 2. So if you want to add this 16 after 5, so the new index for 16 should be 2, right? So we have to say 2 comma 16. So 2 is the index number and 16 is the value. That means this 16 value will have an index number 2, and this 9 will become 3 now. Right? So it will become 3 now. And that's the problem starts. Let's say you have a big collection or big array list, and in that you are just adding an element on 5th position, and you have a collection of 50 elements. If you add an element on 5th position, it will shift all the remaining elements after 5, right? So it will increase the processing power of your system. It will actually consume the lots of power of your system, right? It's because in array list everything works with the index number. If you add an element in between, it will affect all the remaining elements on the right side. To make changes in this way, instead of using an array list, we can use a new concept, or a concept which is very famous in C programming, in any data structures. It's called a linked list. So linked list is a class which implements list. So it's also a list. So we'll just import the package here. Instead of using list, we are using linked list. Now, linked list doesn't use this concept of index number. It basically uses a node where every node knows about its right side and left side. So if you add an element at any position, it will only affect the right node and the left node, not all the nodes. Right? And that's the advantage of using a linked list. So which is better, array list or linked list? Both are better in their own way. If you want a list, if you want an array where searching should be easy or faster, you can use array list. But if you want a list where addition of an element in between should be fast, you can go for a linked list. So that's your array list and linked list.